Hello, today we're going to look at simple isomers of alkenes and alcohols. Right? And you might be wondering, well, what's an isomer? And that's a good place to start. Okay, it's a molecule with the same molecular formula, okay, and different structure. Okay, and that definition is something that's really important to remember as we go through this video. Thing that we need to know about, okay, is what is an alkene. Now, an alkene, okay, it has what we call a carbon-carbon double bond. And that just means that one carbon is connected to another carbon and it has a double bond. So if we look at this example here, okay, this has got one carbon-carbon double bond, and so this would be an alkene. Alcohols, okay, have what we call the hydroxyl group, and the hydroxyl group is an OH group and it's connected to a carbon. So we've got a few examples here. Okay, carbon single bonded with hydrogen, and then we have the hydroxyl group at the end. And then last week, just before we start, we remember this table just to help us to look at how many carbons in the molecule. So if it's got one carbon in its chain, it's going to be meth, eth is 2, prop is 3, etc. So they're the things that you need to know before we get into looking at the isomers. So we're going to start at alkenes. So if we've got one example here, so this is our first example. We've got one alkene, and then we have another one like this. So firstly, we need to look at naming these alkenes. Okay, and they've got a carbon-carbon double bond, but you can see in these two that they are in different spots. So the carbon-carbon double bond, okay, is in a different spot. So firstly, we're going to have a look at naming them. So what we need to do to name an alkene, we need to start closest to the double bond. So we're going to start here and we're going to number our carbons. So carbon, 2, 3, 4, 5. So we've got 5 carbons. So automatically, we can look here, pent has 5 carbons. So we're going to start with pent. So this is going to be pent. And now we need to look at which carbon number the double bond is connected to. Okay, and we want the lowest number. So it starts at 1 and goes connected to carbon number 2. So we're going to call this pent 1 ene. Okay, because it's an alkene, because it's got this double bond. So that's the first one. Now the second one over here. Okay, so firstly again, we're going to number the carbon. So you're going to do 1, 2, 3, 4, 5 carbons. And then when we look at this here, the double bond or the alkene group, like the carbon-carbon double bond, is connected, goes from the number 2 to 3, so it's going to be pent because there's 5 carbons, number 2 because it's from the second carbon, and it's going to be ene. Look at our definition of a isomer. Okay, it's a molecule with same molecular formula, different structure. So firstly, we can look at these two and we say, do they have a different structure? Yes, they do, because they've got the functional group, or the carbon-carbon double bond, is in a different spot, so they've got a different structure. And we want to look at the molecular formula. So to work out the molecular formula, all you have to do is count up the number of carbons and count up the number of hydrogens. So if we think number of carbons, so we've got 5 carbons here, so C5, and if we count the number of hydrogens, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's going to be H10. So if we now look at the second molecule here, again, C5 and H, 1, 2, 3, 4, 5, H10. So that's going to be pent-2-ene. So we can come here, same molecular formula, we can give that a tick. Different structure. Yes, they have a different structure, so we can also give that a tick. We have a look at this molecule. Okay, so this is a different one again. And you might be thinking, oh, but there's no carbon-carbon double bond anywhere here. So that's definitely not going to be an isomer. It's definitely not going to have the same molecular formula. But let's have a look at this molecule. Count the number of carbons, so 1, 2, 3, 4, 5 carbons. So it's going to be pent. And because it's all got only single bonds, it's going to be pentane. A ring. So because it's in a circle, okay, all the carbons are in a ring, we're going to call this cyclopentane. Okay. Now, we want to now look at the molecular formula. Okay, so we've got 5 carbons, so C5, and each carbon's got 2 hydrogens, so 2, 4, 6, 8, 10, H10. Okay, so, right, a molecule, same molecular formula. Tick, we can put a tick next to that. Different structure, yes, we can put a tick next to that as well. Okay, so it's got same molecular formula, different structure. These molecules, these are the isomers of C5H10. Okay, so we've got pent-1-ene, pent-2-ene, cyclopentane. So that's for isomers of alkenes. Now we're going to have a look at alcohols. So alcohols, if we go back to our information at the start, okay, alcohol has the hydroxyl group, which is OH. And these, I've just highlighted them for simple. They've all got an OH. And you can all see that it's in a different position. So what we're going to do is we're going to start with numbering our carbons. Okay, that's always the first part. Now, we always want to number them closest to this functional group or closest to the hydroxyl group. So remember here, if we look back at pentene, we numbered it closest to the carbon-carbon double bond. It's the same with the OH group. So we're going to number it from this side. 1, 2, 3, 4, 5. So they've got 5, which is pent. And the OH group is connected to the first carbon. So we're going to say pentan 1-ol. So that's this molecule here, pentan 1-ol. Now when we look at the molecular formula, we've got 5 carbons. And we've got 3, 4, 5, 6, 7, 8, 9, 10, 11. H11. And then we've got an OH group. So this we can put on the end. So C5H11OH. So if we name the next one, we've got OH here. So we want to number the carbons. 1, 2, 3, 4, 5 carbons. Closest to the functional group, so over here. And then it's 5, so again, pent. And it's the OH, this OH group is connected to the second carbon, so it's going to be pentan 2-ol. So let's look at our molecular formula, C5, H, 3, 4, 5, 6, 7, 8, 9, 10, 11, H11, OH. Okay. And then the last one here, we've got one more. So numbering the carbons. So we always want to do closest to the OH group. Now this OH group is in the middle, so just for something different I'm going to number it from this way. If you also number it from this direction, you'll get up to number 3 as well. So pentan, 3-ol, because it's on the 3rd carbon. And then we do C5H, 3, 4, 5, 6, 7, 8, 9, 10, 11, 11 OH. These molecules, do they have the same molecular formula? Right, C5H11, OH, same with this and same with this. So yes, we can give that a tick because they've got the same molecular formula. Do they have a different structure? So is the OH group in a different position? Right, yes. Okay, so if it meets both of these, then they're going to be isomers. So I'm going to pause here for just a moment. Make sure that you write this down. Important definition of an isomer. Same molecular formula, different structure. Okay, so that's it for today's video on simple isomers of alkenes and alcohols. I hope this was helpful for you. Bye.